Hey guys, welcome back to my channel. I am Purnima from Sri Venkateshwara College of Engineering. Today we are going to discuss about the topic that comes under chemistry, in particularly corrosion control methods. So let's get in. Corrosion control methods. Corrosion control is crucial for preventing the deterioration of materials due to chemical reaction with the environment. These are some methods to control the corrosion. The first one is design and selection of materials. Second one is protective coating, and the third one is cathodic coating. Let's see one by one. Protective coating. Protective coating are a crucial component of corrosion control, providing a barrier between the material surface and the corrosive environment. These coatings help to prevent or slow down the corrosion process, extending the lifespan of the material. Here are some common types of protective coating: metal coating and inorganic coating. In that metal coating is a process in which a layer of one metal is applied to the surface of another metal. This coating is typically done for various processes, including corrosion resistance, decorative finishes, increased hardness, or improved electrical conductivity. The next one is anodic coating. The coating metal is anodic to base metal is called anodic coating. Example, galvanization. Galvanization is the process of coating iron or steel with a layer of zinc to protect it from corrosion. This protective zinc layer acts as a barrier, preventing rust and extending the lifespan of the metal. These are the steps that how the galvanization process would be done. First one is cleaning. The steel object is thoroughly cleaned to remove any dirt, grease, rust, or mill scale. This is often done using a combination of degreasing, pickling, and rinsing. Next one is fluxing. The clean steel is dipped into a flux solution, typically a zinc ammonium chloride solution. This helps to remove any remaining oxides and prepares the surface for bonding with the molten zinc. Next one is dipping. The prepared steel object is submerged into a bath of molten zinc maintained at around 450 degrees Celsius. The next one is withdrawal. After a sufficient time in the molten zinc, the object is slowly withdrawn. The next one is cooling. The galvanized object is allowed to cool naturally or is quenched in water to accelerate the cooling process. Inspection. The galvanized coating is inspected for uniformity, thickness, and adherence. Any imperfections may require further treatment or touch-ups. Optional finishing. In that, painting. For additional protection or aesthetic purpose, a paint layer may be applied over the galvanized coating. Next one is passivation. A chemical treatment can be applied to create a passive layer on the zinc surface, enhancing corrosion resistance. The next method is inorganic coating. Inorganic coating refers to protective layer applied to surface using materials that do not contain hydrogen bonds. These coatings are composed of minerals, metals, ceramics, or other inorganic compounds. Inorganic coatings are known for their durability, resistance to high temperatures, and stability in harsh environments. Example, anodizing and phosphating. Anodizing is a process that involves enhancing the natural oxide layer on the surface of certain metals, particularly aluminium, by creating a thicker, more durable, and corrosion resistant layer through electrolytic oxidation. Let's see the anodizing of aluminium. The aluminium surface is cleaned thoroughly to remove any contaminants such as grease, oil, or dirt. This step is essential for ensuring proper adhesion of the oxide layer. The aluminium is often immersed in a degreasing solution to remove any remaining oils or greases from the surface. In some cases, aluminium is etched in an alkaline solution to create a microscopically rough surface. This enhances the adhesion of the oxide layer. The cleaned aluminium is immersed in an electrolytic solution, typically sulfuric acid. An electric current is passed through the electrolyte solution. Oxygen ions are released at the anode and they combine with the aluminium to form aluminium oxide. The aluminium oxide layer grows on the surface of the aluminium. The thickness of this layer can be controlled based on factors such as the duration of the anodizing process. If desired, various coloring methods can be employed during or after anodizing. This can involve introducing pigments or dyes into the porous oxide layer, allowing for a range of colors. The anodizing aluminum may be undergo a sealing process. This involves closing or partially closing the pores in the oxide layer to enhance corrosion resistance. Sealing methods include hot water sealing or chemical sealing. The anodizing aluminum is visually inspected for the quality of the oxide layer, color uniformity, and overall adherence of specifications. The last method is cathodic protection. Cathodic protection typically refers to a type of corrosion protection method called cathodic protection. Cathodic protection is a technique used to control the corrosion of a metal surface by making it when the cathode of an electrochemical cell. This divided into two techniques: sacrificial anode technique and impressed current technique. Sacrificial anode technique. The sacrificial anode technique is a method used to protect metal structures from corrosion by employing a sacrificial metal that is more easily corroded than the structure itself. In simple terms, sacrificial anode is a piece of metal that is more reactive and tends to corrode more readily than the metal structure you want to protect. Electrochemical cell. The sacrificial anode and the metal structure to be protected from an electrochemical cell. In this cell, the sacrificial anode becomes the anode and the metal structure becomes the cathode. Corrosion prevention. Since the sacrificial anode is more prone to corrosion, it corrodes sacrificially, releasing electron in the process. These electrons flow through the metal structure, preventing its own corrosion. Essentially, the sacrificial anode sacrifices itself to protect the main metal structure. Replacement of sacrificial anodes. Over time, as the sacrificial anode corrodes, it needs to be replaced periodically to ensure continued protection of the main metal structure. The next one is impressed current technique. External power source. An external power source, often a direct current power supply, is connected to the metal structure to be protected. Inert anodes. Instead of using sacrificial anodes that natural corroded, the impressed current technique employs inert anodes, typically made of materials like mixed metal oxide or platinum coated titanium. Electrochemical cell. The metal structure becomes the cathode and the inert anode becomes the anode, forming an electrochemical cell. Electron flow. The external power source drives as a flow of electrons from the anode to the cathode. This flow of electrons counteracts the natural corrosion process that would occur on the metal structure. Preventing corrosion. By impressing a controlled electrical current onto the metal structure, the technique actively prevents the metal from corroding. This particularly useful in situations where sacrificial anodes may not be practical or cost effective. Thank you for watching. Keep supporting guys.